In this lecture, you'll learn about multi-protocol, which is where we configure the ONTAP system to allow access to both CIFS and NFS clients to the same files and folders. To understand multi-protocol, the first thing that you need to understand is security styles. The security styles determine the type of permissions ONTAP uses to control data access and which client type can modify those permissions for our NAS protocols. Security styles do not determine which client types can or cannot access data. Both Windows and Unix-based clients can both access volumes with any security style as long as they're allowed by the configured authentication and authorization. So let's see what the security styles are. There's 4 different ones. There's UNIX, NTFS, Mixed, and Unified, which is used on infinite volumes only. So we can set the security style to UNIX. When we do that, it's not just Unix-based clients that are going to be able to access the data. Windows clients will be able to as well if we allow that through the multi-protocol settings. The other next security style that we can set is NTFS, and again, that's not just for Windows clients. Unix-based clients like Linux can also access volumes which are set to the NTFS security style if we allow that in the multi-protocol settings. Next one is Mixed, and the last one is Unified. On infinite volumes, which are pretty much deprecated now, but you can still use them, then the security style is always going to be Unified. You don't get a choice there. With your normal flex vols, you can choose either Unix, NTFS, or Mixed. So let's talk a bit more about what that means. The security styles can be set at the volume and at the Q3 level. Q3s inherit the security style of their containing volume by default. So when you first set up an SVM, when you do that, you're also going to be creating the root volume, and the root volume is going to have a security style set on it. The rest of the volumes that you create in that SVM are going to have the same security style as the root volume by default. And whenever you create a Q3, it's also going to have that same default security style. But when you create a volume, you can set a different security style on there if you want to. And when you create a Q3, again, you can set a different security style than its containing volume has, but by default, it's going to be the same. If the security style is set to Unix, what this means is that Unix permissions are always used on the files and folders in that volume or Q3. And if the security style is set to NTFS, then Windows NTFS permissions are always going to be used. If the security style is set to Mixed or Unified, either permission style can be used on the directories and files in that volume or Q3. Whichever type of client last modified the permissions, either a Windows client or a Unix-based client, that will be the style used. So in a mixed volume, if there is a file there and a Unix-based client changes the permissions, that file will have Unix-style permissions. And in that same volume, if there's another file and the last person to modify the permissions on that file was working on a Windows client, then it will have NTFS style permissions. So in mixed or unified style volumes and Q3s, you can have files and folders which have got either Unix or Windows style permissions. It supports both in the same volume. If the volume style is set to Unix, then those files and folders are always going to have Unix style permissions. Now, both Unix and Windows style clients can still access those files and folders, but the permissions will always be Unix. And obviously with NTFS, again, both Windows and Unix-based clients can access those files and folders, but the permissions set on them will always be the Windows NTFS style. So let's have a look at what I really just summarized there with a table. So if the security style is Unix, the clients that can modify their permissions are going to be NFS clients. The permissions that the clients can use they can set on those files and folders are going to be NFS version 3 mode bits, or if it is an NFS version 4 volume, then you can use NFS version 4 ACLs. So if the volume only supports NFS version 3, it's always going to be NFS version 3 mode bits. If the volume supports NFS version 4, you can use either NFS version 3 mode bits or you can use NFS version 4 ACLs. And the resulting security style on a volume which has got the Unix security style set on it is, of course, always going to be Unix. Next up, if the security style is NTFS, the clients that can modify their permissions are going to be our CIFS, really our SMB clients. The permissions that the clients can set on those files and folders are going to be your standard Windows NTFS ACLs. The security style is NTFS. If the volume or Q3 has been set to the mixed security style, then the clients that can modify permissions are both NFS and SMB. If an NFS client modifies the permissions on a file, then it will have either NFS version 3 mode bits or the NFS version 4 ACLs. And if it is a Windows client that modifies the permissions on a file or a folder, it's going to have NTFS ACLs. And this can change as well. So say that there is a Windows client is working on a file, and then that client sets the permissions on the file. Well, at that time, it's going to have Windows NTFS permissions. If 5 minutes later, somebody working on a Linux machine opens that same file and then changes the permissions on there, it's now going to have Unix style permissions on there. So the files and folders, they can have either Unix or NTFS permissions on there, but it's going to be one or the other, whichever was the last client that modified the permissions on that file or folder. So if it is an NFS client that last modified the permissions in a mixed volume, then it's going to have Unix style permissions. And if it was a Windows client, then it's going to now have NTFS style permissions. And the last one we have is unified. This works exactly the same way as mixed. So if you're wondering, well, why do we have mixed and unified? Unified is reserved just for infinite volumes. So when you create a flex vol volume, you can choose to use either Unix, NTFS, or mixed. When you create an infinite volume, it's always going to have the unified security style. You don't have any choice in that. Okay, moving on. So looking at the security style defaults. If CIFS is enabled on an SVM, and you can have any other protocols enabled on it as well, when it is first created, then the default security style is NTFS. So that SVM's root volume will have the NTFS security style set on it, and any new volumes that you create after that are also going to inherit that default NTFS security style. So if you create an SVM with just CIFS enabled on there, it's going to have the NTFS security style on there. If you create a SVM and you enable both CIFS and NFS, again, it's going to have the NTFS security style. So if it's got CIFS enabled on there at all, the default security style will be NTFS. If CIFS is not enabled on an SVM when it is created, then the default security style is Unix. So if you create a new SVM and you just enable NFS on there, for example, the default security style will be Unix. If you create a new SVM and you just enable one of the SAN protocols on there, again, the default security style will be Unix. By default, the effective security style on all data in Unix mixed and unified security style volumes is Unix, and the effective permissions are Unix mode bits 0755. That gives the owner read, write, execute, the group read and execute, and everyone else also read and execute. By default, the effective security style on all data in NTFS security style volumes is NTFS and has an ACL allowing full control to everyone. Okay, so how does this work from the client point of view? Well, for a Windows user to access an NTFS security style volume or Q3, the Windows user is tested against NTFS security style ACLs, just as it would work as normal in a Windows environment. If the Windows user is trying to access a Unix security style volume or Q3, then the Windows user must be mapped to a Unix UID. This is because the files and folders in that volume or Q3 are set with Unix style permissions, and it's not going to understand a Windows username. They're not compatible with each other. So for a Windows user to be able to access the data in a volume or queue tree that has got the Unix security style on there, we need to map that Windows user to a Unix user, and then the system will test their authentication against that Unix user. For a Unix user to access files and folders, it's going to work the same way. So for a Unix user to access a Unix security style volume or queue tree, the Unix user is tested against the Unix files permissions, just as is normal in a Unix and Linux environment. If a Unix user is trying to access an NTFS security style volume or queue tree, then the Unix user again must be mapped to a Windows user. Because the files and folders have got NTFS permissions on there, it's not compatible with Unix users, so we need to map that Unix user to a Windows user to do the authentication and the authorization. So let's have a look at how this works with a flowchart. Starting off with Windows to Unix mapping, we'll do Unix to Windows after this. So this is where a Windows user is trying to access a volume or queue tree which has got Unix permissions on there. So we're trying to open up a file or folder with Unix permissions on it. First off, that user needs to be authenticated. They're either going to be authenticated against the Active Directory domain, which is more common, or maybe in a smaller or a specialized environment, we can have them authenticated against local Windows user accounts, which are configured on the ONTAP system. So if they're being authenticated against Active Directory, they'll be authenticated by the Windows domain controller, and they're either going to be authenticated because they enter a valid username and password, or unauthenticated, meaning they don't enter a valid username and password. And obviously, if it's the local Windows user accounts, the authentication is going to be the same. They either enter a valid username and password or they don't, but here they're being authenticated by the ONTAP system itself. So at the end of that, we're either going to have a Windows authenticated or an unauthenticated user. Okay, what happens next? So here we've got a Windows authenticated user, meaning they've entered a valid Windows username and password. And the system, the ONTAP system, sees that they're trying to access a file or folder, which has got Unix style permissions set on there. So we need a mapping for that. So first thing that the system will do, we'll check to see if there is a mapping from the Windows domain and username to a Unix username. If a mapping exists, it will try a mapped user. So here, this one, if a mapping exists, try the mapped user. What we're talking about there is where you, as the administrator, have configured a mapping. So you've configured a mapping where you've specified if this particular Windows user is trying to access a file or folder with Unix permissions, then use this Unix username. If there is no mapping, then try the Windows user, meaning it will see, is there a Unix username which matches the Windows username. So say that the Windows username is John Smith, then it will automatically try John Smith as the Unix username if there is not a custom mapping configured. And then the last one is if mapped to quotes. This is, so there's nothing in there, it means it's a null string. This is where you as the administrator have explicitly said that this particular Windows user or users, if they try to access files or folders in this volume or queue tree, which have got Unix permissions set on there, then they're mapped to a null string, meaning that they are an invalid user. So that is how you explicitly deny access to a particular user or users. Okay, next up, so either a mapping exists, one that you'd configured, or if there's no mapping, they've tried the Windows username. In that case, at this point, the system is now going to do the authentication. So they're going to verify the Unix user by either files, NIS, or LDAP, whichever one you've set up to do the authentication. And then based on this, then this is where it's going to check the permissions. So it does the authentication. It also does the authorization as well. So it's going to check the Unix permissions on that file or folder, and then based on that username, the user either gets access or they do not get access, based on how you've configured the permissions. Okay, if that does not work, then the next thing that is going to be tried, so here there's there's not a mapping. So either you have not configured a mapping, or there is not, the Windows user does not match with a Unix user. Well, in that case, what's going to happen is it will check to see if domain admins are mapped to root. This is turned on by default. So if that Windows user is a member of the domain admins group in Active Directory, they will be mapped to the Unix root user, and then the system will check and see, does the root user get access to that file or folder? You can turn this off if you want to. If you turn this off, then what will happen is the system will use the default account of PC user, UID, and the GID 35534. And when that happens, again, the system is going to check the Unix permissions on the file or folder and see if that user is allowed access or not. Okay, so yeah, so just again, say that again, this bit down here, when it gets to this bit here, it's checking, is that user allowed access to the file or folder based on the standard Unix permissions. How about still doing Windows to Unix mapping? How about if the user is unauthenticated or an invalid user? Well, at that point, the system will check, is the guest account configured? It is not by default. If the guest account is not configured, they're an authenticated or invalid user, then they will be rejected. They do not get access to that file or folder. If you have configured the guest account, then it will try the guest user. Again, it's going to verify that by files, NIS, or LDAP, and then the guest user is either going to be accepted, given access to the file or folder, or they're going to be rejected. Okay, so that's how it works when a Windows user is trying to access a file or folder with Unix permissions. How about the other way around, when a Unix user is trying to access a file or folder with the Windows NTFS permissions? So here, the Unix client, probably a Linux system nowadays, accesses the storage system. It's going to send the user's UID, the user identifier, and the GID, the group identifier. That comes into the storage system, and then based on how the authentication is configured, the system is going to resolve the UID to the Unix username, either by files, meaning local users, by an external NIS server, or an external LDAP server. And that UID to Unix username is either going to be successful or it is going to fail, depending on whether they sent valid credentials or not. So if the UID to Unix username is successful, it's going to be very similar to what happened with the Windows client. First up, the ONTAP system will check for a mapping from the Unix name to the Windows domain user. Again, this is a Unix user trying to access a file or folder which has got Windows NTFS style permissions on there. So the Unix username won't work. We need to map it to a Windows username. First up, if the mapping exists, try the mapped user. So this is where you as the administrator have explicitly configured a mapping for that particular Unix user to a Windows user. Next up, if that does not happen, then it will try the Unix user. So this was the same as what happened from Windows going to Unix. It will check to see, is there a matching Windows username to the Unix username? So if the Unix username was John Smith, it will try the Windows username also of John Smith if one exists. Also, as the administrator, again, you can explicitly map that Unix user to a null string. When you do this, this is how you prevent that particular user from accessing the files or folders. That maps them as an invalid user. Okay, so if a mapping exists, or if there is no mapping, we've tried the Unix user, the next thing that happens is verify the Windows user by the local storage system or by the domain, again, checking if it is a valid user or not. If that is a valid Windows user, then look at the NTFS permissions on the file or folder, and then either give the user access if they're permitted, or do not give them access if they're not permitted. Next thing that will happen after this stage here, if they're not verified as a valid Windows user, so it's not a valid Windows username, then if one is configured, you can use the default account. So you can say, for when this happens and we're not able to verify that Windows user, you can map all of those users to a default Unix account. And then come back down here again, and at this stage, is that default Unix account allowed access to the file or folder by the Unix permissions or not? If the UID to Unix username failed or invalid user, very simple, the invalid user will be rejected. Okay, so that was how the mappings work. Last thing to tell you here is about the recommended security styles. This bit is quite obvious. If you have some data that will only be accessed by Windows clients, put it in a dedicated CIFS SVM, or put it in a mixed SVM and set the volume security style to NTFS. So if the data is going to be accessed by Windows clients, then you want the security style to be NTFS. If you have some data that will only be accessed by Unix clients, put it in a dedicated NFS SVM or put it in a mixed SVM and set the volume security style to Unix. So again, if there's some data that is only going to be accessed by Unix and Linux clients, you want the security style to be set to Unix. How about if we have mixed volume access though? So if we have a volume and the files and folders in there are going to be accessed by both Windows and Linux clients as well. Well, in that case, use the Unix security style if the file system is managed by a Unix administrator and most of the users are Unix clients. That Unix administrator is going to be used to dealing with Unix style permissions, not so much for NTFS, so this will make it easier for them. Next one, use NTFS if the file system is managed by a Windows administrator and most of the users are Windows clients. So the files and folders can still be accessed by both Windows and Linux clients, but this is going to make the administration more logical and easier. Use mixed security style if the file system is managed by both Unix and Windows administrators and the users consist of both Unix and Windows clients, about an equal share of each. Thanks for watching. If you want to get hands-on practice with NetApp storage for free on your laptop, then you can download my free ebook, which you can see above my head right now. Also check out my NetApp Storage Complete course, which will teach you everything you could possibly want to know about ONTAP. Thanks.